day 18. It's day 18 of Advent of Code. Let's jump in and see whether we have another 2D grid problem or not. Alright, here we go. Day 18. Yesterday was so promising. Right, okay, I'm skipping the first two. As always, the algorithm is fast. Fortunately, you're faster, and by quickly scanning the algorithm, you create a list of bytes will fall your puzzle input in the order they'll land in your memory space. I do not understand what this is about right now. Your memory space is a two-dimensional. It was looking so positive. We had opcodes and registers and computation, and now we're back to two-dimensional grids. Okay, calm down. Woosah. It's not a big deal. However, for the sake of example, suppose you're on a smaller grid with coordinates arranged from 0 to 6 and the following list of byte positions. Right, so these are coordinates on a 2D grid, 0 to 6, but they're saying your memory space with a range 0 to 70. So a 71 by 71 grid, but they're giving us an example here, 0 to 6 coordinates. So the puzzle, okay, let me just see the puzzle input. Okay, right, okay. Okay, just, is that the same right at the bottom? Yeah, okay. So we're talking about coordinates on a grid. Each byte position is given as an xy coordinate where x is the distance from the left and y is the distance from the top, okay? You and the historians are currently in the top left corner of the memory space at 0, 0 and need to reach the exit in the bottom right corner. Okay, so we're pathfinding here. But 6, 6 in this, yeah, okay. You'll need to simulate the falling bytes to plan out where it will be safe to run. For now, simulate just the first few bytes falling into your memory space. As bytes fall into your memory space, they make that coordinate corrupted. Corrupted memory coordinates cannot be entered by you or the historians, so you'll need to plan your route carefully. You also cannot leave the boundaries of the memory space. Your only hope is to reach the exit. Alright, so these corrupted cells basically are walls, exactly like in the previous two dimension. Look, even the Advent of Code people are clearly running out of ideas here, because we've got all this backstory of basically, here are the wall coordinates. Here are the coordinates for the wall. You can draw your own walls, and then it's exactly the same as it was before. You need to find from the top left to the bottom right. They're not even giving us an S and an E this time. So if you were to draw the memory space after the first 12 bytes have fallen, using dot and hash for corrupted, it would look like this. Okay. You can take steps up, down, left, or right. After just 12 bytes of corrupted locations in memory space, the shortest path from the top left corner to the bottom right, the exit, will be 22 steps, here marked with O's. Simulate the first kilobyte falling onto your memory space. Afterwards, what's the minimum number of steps needed to reach the exit? Right, okay. Alright, let me think. This is exactly the same as the previous challenges, basically. It's just that there's a little bit of sort of setup. So I'm going to just deal with the setup first. So as per usual, we're Deno init and we're on AOC 18 today. So let's jump straight into there. I want an input.txt, and then that'll be good enough for now. So no thanks to all this JSON. Let's get rid of the test file. We don't need this code. Let's just read the text file. Oops, no. Context is await deno.read text file input.txt, and then let's just log out that. And then of course we don't have any input right now. Let's use theirs. Let's use this. This list, we probably don't need the whole list because we're only supposed to read the first 12. In their example at least, but we'll take the whole thing. Okay, let's open up a tab here and let's run this allow read. There we go. Okay, so we're reading the file, that's fine. Now we want to just convert those into coordinates we can do something with. So let's do that. We're going to take the text, we're going to trim it, we're going to split it on new lines, And then for each new line, we'll map the line to a function that can return an object with a y and an x coordinate. We'll fill in the blanks in a second. And then here, let's try that one again. Console log quads. Okay. Yeah, they're all zeros. We need to just read those from the lines that we've got here. So in the case of the line, they're separated by is it commas? 1 second, let me save this. Yes, commas. Okay, so it will be line dot split on the comma, and then we will take the what order are these actually x y? Yes, they're x y. I'm reading yx because all these things we've done so far here I've done in yx order, so let's keep this the same. So y is actually going to be the second element of this thing, and it's also a number, so let's parse that as well. Okay, does that work? Yeah, we have some y numbers there. Let's do the same. Let's do the same for x here. May as well just do it this way. And then we're doing the same, but we're going to read from 0 instead. Clear this. So 4, 5, 2, 4. Yep, 4, because I'm reading them in the other order. So 4, 5, 2, 4, and then at the bottom we got 6, 1, and 0, 2. 6, 1, and 0, 2. There. All right. Well, that's the easy bit, reading the input. Now, this to me is essentially the same as like not yesterday, because yesterday was actually fun. The day before yesterday, and several other ones where we've been given a grid, and yeah, it's a pathfinding solution. It's in this case, it literally is just basically the shortest path. It's actually simpler than I think it was day 16 where we had to take shortest path and calculate turn cost. In this case, we're just calculating like literally shortest path. So this is definitely a breadth first search, which we did on day 16. And actually, I'm not even going to re-implement that. I'm not even going to recode it because we coded it already once. I'm going to take it from day 16's code. So if you've not seen day 16, go watch that video. That video is an easier video to watch too because I explained my solution rather than coded it live. So yeah, we'll take the solution from day 16 because that was written in a way that can be reused actually. And then, so the only thing remaining is essentially to draw the walls on this map to make a grid. So let's make a grid, and we'll do that by saying array.from, and then we can say the length of the array. Now in this case, we're doing a 0 to 6, that's 7, right? 0, yeah. So it's 7, and then that's the first dimension. So the value to be used for each of the elements is another array, and that's also going to be from a length of 7. And then the value in that case can be a dot. So that's our grid, and I'll do what I did also. I just want to create a little print function here so I can see it, because if I print it with console log, you see the array and then the arrays, and it doesn't look like a grid. So if we just do for each here, no, 1 second. This needs to be a function. So a function that can print the grid, and it can just take each line, and then we can say console log line.join. Okay, and then we don't let's just call print and see if that works. We should be able to see a 7 by 7 grid here. Yeah, it looks about right. Yeah, and then well, it seems like the easy thing to do. The next step here is, before we just use our breadth first search from day 16, we need to put walls onto the map. The walls are basically, as described here, are the falling whatever they call it, the falling bytes that create these hash symbols, and then we can't move it out. They're just walls basically. So yeah, let's just put them onto the grid then. So we're going to say like coordinates for each. We'll just modify the grid. So coordinates.for each, and then we're going to say, yeah, for each given coordinate, we'll take grid coordinate.y, coordinate.x, c.x is equal to a wall. That's pretty straightforward, and then we can print that. That doesn't look like theirs. Yeah, after the first 12 bytes have fallen, I did actually already foresee this problem. So let's just make sure we're only plotting the first 12 there. Slice 0 and then continue on to 12. Okay, that looks, so on the top line we've got a hash in the middle, hash in the middle, and then bottom line 2 hashes. Yeah, it's basically stripes. Okay, so I mean that bit's super easy. That's all we need to do here, and then we want to do basically a shortest path algorithm through this maze now. So yeah, I'm literally going to jump over to here now, and let's open up AOC 24, and then AOC, I've been keeping all this code, thank God, day 16. Let's open day 16 up in here. Remember, actually, this was a JS solution. So it's this function here, search, which is a breadth first search from a starting y and x coordinate. Start y start x, end y end x, and it just uses a priority queue to do a breadth first search. And this was coded to keep track of turns because it was trying to do a priority queue around the shortest number of turns. So, well, I mean, yeah, maybe we can modify the priority queue algorithm inside this to make sure that it doesn't actually care about turns anymore. But yeah, let's take this function, which is basically there, and then let's jump back over to our solution and just drop that in. I'm not going to recode it. This video is just going to be a long video of me recoding a breadth first search, which I already did in day 16. So yeah, let's do that. So let's stick this search function here. Now that search function is searching for the shortest path. Because it was in a JS code base, there's some bits of this that it's not liking now. Yeah, because we're in TypeScript land. So I'm just going to do let's just do a couple of things here to make sure that this is happy. I'm sure there was a fast way in Vim to just do what I just did there, but position, yes, direction. I mean, we don't really even care about turns, so let's just not even keep the turn. I mean, we don't even really need to keep the direction either. We only kept the direction so we could increment turns. That was what the day 16 challenge was. We don't need to do that here. Now this visited is a map to visits. I'm not going to try and type that. I don't care. I'm not. Same with directions. I don't care about that anyway. Let's just put these any's on there so it's not going to complain. Here it's complaining because y and x are implicitly any. Let's just put those as numbers because they're meant to be. So this valid function is one of the exit cases for this breadth first search, and it's actually exactly the same here. If we find the same wall character, then we're out. The best is the one that is found based on this priority queue. The priority queue is based on the collection of turns. Now, we've just deleted turns, so let's not do that here. Yeah, actually that's what it's complaining about. But we're actually interested in the shortest path, so we want to sort this by path now instead. So if you've not seen day 16 and you don't know what a breadth first search is, it might make more sense to go look at that video. But if you can't be bothered, then I don't blame you, because these 2D grid problems are getting quite tiring now. But breadth first search is just a shortest path algorithm that's quite efficient, that creates a queue and then explores all the cells around the current one and then adds them onto the queue and keeps exploring. And in each case it's saying that we order the queue based on the priority we're looking for, which in this case is like the path length. In day 16's case, it wasn't the path length first, it was the number of turns, because turns were like 1,000 times more expensive, and then we just process the queue until the queue is empty, or until we find our exit case. And when we find the exit case, in this case we don't actually stop, we just keep a copy of the best one. So we're gonna have to make some changes for that here. Current is possibly undefined. It's not, so I'm going to just do the TypeScript. This exclamation point is not a JavaScript thing, it's a TypeScript thing in this case. It's basically saying the problem here is that it thinks that current could possibly be undefined, which is true, because if we do q.shift and keep doing it, eventually there'll be a q.shift where it could be undefined. Even though TypeScript is not smart enough to see that what we're actually doing here is only doing that while q.length is greater than 0, so technically that can't happen. But from a type perspective, it thinks it can. So we can just say, no, trust us, it's fine, don't worry about it. Yeah, so again, this here is if we've not got a best already, or the current condition is better than the previous best condition was. Now that condition was based on turns before, but now we want it to be based on path length, so let's just modify that to actually use the path length as the priority inside this queue now. Oh, again, yes, it's complaining that we may have a current object that was undefined. Again, we're just going to say it's TypeScript, don't worry about it, we know that it's not. I'm sure the problem is the same here. I'm sort of just doing the easiest thing right now because I don't want to current dot. Oh, we don't. Oh, yeah, we were keeping the direction on the visited cells, weren't we? yeah, we don't want to revisit the cells. Actually, we probably do need to keep that direction then. So let me put that direction back up there as null, and then all the rest of this still works. Now, it's the only thing we don't care about here. So as we go through here, we're going through in all the different directions and pushing onto the queue all of the exploration points from the current coordinate in all the different directions. But we don't need to keep hold of turn there. Now, yeah, again, current might be undefined, so let's just say no, it's not. We don't worry about it. We don't need this bit. We don't need to. We're keeping direction here to make sure that we can. Yeah, just so we can index that. That's all. It's just for the previous cell visits. That piece of code there that I just deleted was to figure out whether the turns has increased by 1. But here we don't care if the turns have increased by 1 or not. And then what's the problem with this push? Any not assignable to never. Oh, great. So what's the problem here? I think if I type this as any, we should be fine. Yep. Right, so I've sort of opted out of most of the TypeScript on that one because I'm not interested in typing all that stuff here. I just want to pull that in, keep this video nice and short, because this essentially, day 18 is a bit of a weak one in my opinion. It's exactly the same as day 16 with less constraints, with fewer constraints, sorry. So, okay, we have a search now. So we don't need to print this grid anymore. We're going to call search, and what search expects from us is a start y, a start x, end y, and end x. So start y and x is 0, 0. Let me grab this grid thing. We create the grid there, right? And then we have a print, and then we put the walls on it. Let me do all that stuff below here, so I can see, because really this is the sort of entry point. All the rest of it is just functions that we've defined. Okay, so we're going to pull out the first 12 there, stick them in there, and then we're going to search from 0, 0. I mean, we know it's 6, 6, so we can just type those in there. And then let's get the result from the search, which is the best path that we found, and let's just log that out. Okay, let's see what happens here if we run this. Yeah. So 0, that's 1, 2, 3, and then it's 3 times 1, 2, 3, 4, 5, 6, 7, 3 times 7, 14, 21, 22. So, as they say there, it would take 22 steps. It's not surprising because we already implemented this algorithm in day 16, so the algorithm works. It's a breadth first search, and it passed day 16, so it's going to pass any shortest path algorithm here. So, yeah, nothing crazy about that. So I feel like all we really need to do now is grab that puzzle input, which is a hell of a lot more coordinates. Stick that in here. So, where are we? Yeah, let's replace those coordinates with these. The grid in this case, they say, is it 0 to 70? 0 to 70? Starts at 0, 0, and the right corner is at 7, so that's 71 in length. It's a strange number, but so let's increase our grid size to 71, and then the criteria here that we're looking for is 0, 0 to 0, 70, which is the 71st coordinate in there. And then, of course, this here, we're looking for the first 12, but it tells us to look at the first kilobyte, doesn't it? Which I think is technically a kibibyte, but not to quibble. Right, so I don't know how many we've actually got in the coordinates. It may already be 1024. But since I have this code here, I'm just going to change that value. In fact, now I'm curious now. Yeah, it's a lot more than, actually, there's a lot more coordinate pairs than 1024. But so again, I think that's just testing your reading ability there, even though it's very clear. Only do the first 1 kilobyte, and maybe part 2's got some more complexity in it. Okay, what does this say? I can't easily calculate the length of that, but it's come up with a result, which is good. So let's just log res.path.length. That should be the answer. 340. Okay, let's see if it's happy with 340. There we go. I feel bad even doing the confetti. Oh, that's a very Christmas themed confetti. There we go. Nice and short video for day 18, because I'm sure, as you guys did, as soon as I was reading through that, it was like, okay, we've got a maze, it's 2-dimensional, you're asking me what the shortest path is, and the only difference really between this and day 16 is that day 16 already gave you a maze with walls. This is basically just saying there's no outer wall, and the inner wall is defined by these coordinates up front. So really the only part of that challenge that was new was just making the grid out of 2 pieces rather than being given the full grid, but the rest of it is the same. I'm happy that this was nice and easy, and I'm more than happy to take the implementation from day 16 and just use it here today in day 18, because I don't want to sit here and code another breadth first search, because honestly it's kind of a bit tiring, these 2D grid problems. Yesterday was great. The opcodes, the sort of building the interpreter for the invented language. Hopefully there's a couple more of them before we get to the end, because these 2D problems are a bit tiring. Anyway, there we go. Nice and short video, 20 minutes. Day 18. I will see you tomorrow for day 19. And if it's a 2D grid problem tomorrow, then I cannot guarantee what my actions will be.